Hello, everyone. In today's NetXMS talk, we decided to focus on topology because that's what stands NetXMS apart from many other monitoring solutions. It's our network-related functionality. Also, in the end of the webinar, Tatiana will touch a little bit about latest usability improvements in a new user interface, namely how to hide different stuff from users that do not expect it. Let's start with the topology part. I will share my screen. So we are connected to NetXMS server in our office, and we have GNS Network modeled on our GNS server, as well as some real physical devices, workstation servers, etc. As you probably already know, NetXMS collects a lot of network topology information automatically, and it builds network topology based on this collected information. We use multiple sources for building the complete network topology. It's, of course, LLDP, which is a primary source of information on layer 2 or link layer connectivity, basically how devices are more or less physically connected together. We also can use CDP, which is a Cisco proprietary alternative to LLDP. We use switch forwarding databases to collect information about workstations of other end nodes connected to the network. We use spanning tree information, which provides us some additional connectivity information between switches. And we use routing tables to get information how devices are connected on IP level. We also use OSPF MIPS to get information about OSPF configuration in the network. When we have all this information, we actually can search for different topology information from a NetXMS user interface. So let's start with the simple stuff. When you select a switch, for example, you have, of course, interfaces view, where we have a list of all interfaces, which is good by itself. But we also have the peer information for each interface. And here you can see like what other device is connected to this interface. We interface on the peer device, the MAC address and IP address of the peer device if known. And we also have this peer discovery protocol column on the right, where you can get information how we discovered this particular connection. So as you can see in our office, we mostly rely on LLDP and forwarding database information for non-switch devices. For the switch, you can also just look at the switch forwarding database. You can sort it by MAC address, you can sort by port, interface, etc. So you can see which is basically all the entries in the switch forwarding database. And you have the filter, so you can start filtering by part of MAC address, for example, and you quickly can find what you're looking for. You can also filter by name of the node. If it's a known node inside NetXMS, you can just look by the node name. Then, if we select a router, for example, we have information about IP routing table. So you have all the routes, you have a next hop for each route, you have interface information, a metric, and the protocol, how this route end up in routing table. So in this example, it's a virtual router within our GNS network. And here it's mostly either local routes or PF routes. And if router in question supports OSPF, you also have this OSPF view, where you can see OSPF areas configured on the router, as well as all OSPF neighbors. So you have the neighbor router ID, its IP address, its node name if it's a known node, so it's entered into NetXMS as a node, interface, and the state. And here we see we have 2 areas on this router and 6 peers, and one of them is not known as a node in NetXMS, and others are known as nodes. If we select a switch, we also have VLAN information, so you see all the VLANs and on what ports we have those VLANs. That provides you a lot of topology-related information on a single device level, but we provide more functionality for the topology. One of the very useful tools is to search for specific MAC address or specific IP address. So you can go to the tools, and here we have the MAC address search. And in the search string, you can enter MAC address in different formats, like with the dots, with colons, without anything. So let's imagine the situation when I, as a system administrator, know that I have a MAC address that caused some problems, but I don't know anything else about that MAC address. So I just type that MAC address in, press enter, and NetXMS will search through all the switches in my network, looking for where this MAC address is, and it will find the last known connection point. So I found that this MAC address exists in the network, and it is connected to my office switch on the port 18. And it's an indirect connection. That means that it's not directly connected to the switch. There is something between the office switch and this MAC address, but NetXMS doesn't know anything about that intermediate device or devices. In that particular case, it's unmanaged switch with multiple devices connected to it. So this is why we have the indirect type. You can also search by part of the MAC address. So, for example, if I have a part of the MAC, and it will find me all the MAC addresses that starts with this before7AF1 prefix, which is one of the HP prefixes for MAC addresses. And all three found MAC addresses are actually known devices to NetXMS, so it's the firewall device and other IP address known only by IP address inside the system. And again, for each MAC address found, you will get the information on the connectivity. You can do similar things to search for IP addresses. So if all you know is an IP address, you can just type IP address in, and it will find the MAC address using the ARP caches on routers. So in that case, we found that this IP address belongs to that MAC address, and it's connected to my office switch on port 18. And it's not a known node within NetXMS. And if we search for the address which is known as a node, you will get a bit more information. So it will find the node name, an interface on which this IP address is configured, and of course where it is connected. So that's really useful tool for looking for something within your network which you don't know where it's connected or what it is even. Besides that, you can also visualize your network topology in different ways. You can select any device, like for example, I will select one of my routers, and you have a menu item, Topology Maps, and you can choose Layer 2 topology or IP topology here, and the Layer 2 topology will build you a map of how selected device connected to its neighbors within 2 or 3 hops. So we have our ARC2 somewhere here, and we have other devices, how it's connected up to 3 hops away. And you can actually change this number of hops in the server configuration. So for how far to build an ad hoc map from the selected seed device. In a similar way, you can build an IP topology map from any selected device. It's not that much interested for R2. Let's try another one. Yeah, that's a bit more stuff on that map. So that's an idea. You have your IP topology represented here. Besides ad hoc map, you can also create automatically updated map objects. So you go to your network maps and you create a new network map. You should select the type. It should be layer 2 or IP or OSPF topology. For example, let's select layer 2, name it somehow. And you have to select the seed node, basically where to start. Let's start with our R1. Okay. Now we have our webinar map, and it will be updated later on. But I will just change the size of the map. Yeah. And now we have our map automatically populated by the server, and it will be updated. So when a new device is added and they are reachable from my seed node, it will appear on the map. When device is deleted from the network, it will be deleted from the map, so it will be kept up to date by the server. Besides map, there's also routing information. You can build a virtual IP routes between multiple devices. So, for example, you can select a device, and there you have route from and route to. So if you want to know how IP routing is going from this my R13 to, for example, some switch in my data center, I just select this, and NetXMS will build me a route. So I see next hop. From the next hop, I see the next hop, an interface, and the node names, and up to my destination. In the same way, you can select route 2, and you can choose, let's choose the same device. And it will build the route in the opposite direction. So from currently selected device to what I choose in the menu, and you get your routes. It's a virtual route, but it's built based on known routing table configuration for NetXMS. And if you are using zones and proxies, this functionality is zone aware. So if you choose routing from your NetXMS server, for example, it will show you the first hop is tunnel to the proxy and then route from proxy to the final destination. And last small detail about the topology, besides searching for MAC address or IP address to find where a specific end node is connected, you can also select an interface, and on interface overview page, you have the topology element, and here you see that you have this update connection point information. If you press it, it will send the request to the server and update topology message, and we see that it's now displayed that that particular interface connected to the switch SW shelf on the port 104. This is a quick way to find out where my specific interface is connected. This is what I wanted to show about topology related functionality in NetXMS, how you can actually get information about topology from what NetXMS was discovered. Thank you. And now word to Tanya about our new changes in user interface.
Yeah, today I will show you functionality that will enhance usability of new UI. So NetXMS is a very versatile tool with a lot of functionality, as you already saw just previously. And this functionality can get in the way of efficient NetXMS UI usage. So let me share my screen and show you some options how to omit this. First thing I wanted to show is that we have a lot of tabs, and sometimes not all of them are required. For example, you are monitoring only switches and routers and stuff like that. And file manager is not like, you don't use the tab, but it still persists here. So things that you don't need to, here you can just hide, and they will be hidden for all the objects. So for example, software is also empty for me, hardware inventory is okay, and let's hide processes. So now I have much less tabs, and here are only useful ones. If I hidden something that I want to show again, maybe it's like temporary, not use tab, and then sometimes I want to see it, I just can either from this menu, enable or disable. So here are all the views that are available for the objects. You can, in one configuration, change them. Or other option is here. Here you can see all hidden tabs that are available for the current object. So, for example, I can return my file manager. Another thing is also connected with the stuff that we show to the users. It's not security part, it's more about the visibility. So in the configuration, in users and group configuration, we'll now create user that won't see, for example, business services and reporting, because I don't use neither business services nor reporting. Okay, let's create new user. Let me see. Okay. In my case, I would add all users to admin group to have access to all objects. I will just hide some elements. So if I will go to UI access rules, I can add here element, which I want to see for this user. So by default, NetXMS use configuration that for the everyone group, we have here star. Star exactly means that we should see all UI elements. So this means, and everyone group is the group in which every user is by default. Like you can't get the user out of this group. So if you want to inherit something for everyone, you just add this to everyone group. Here, I've created this user. As we saw by default, he's under everyone and now he's under admin. Now I want to say that I want to exclude some elements. In my case, it's business service and reporting perspectives. So I can add element. Here are all the names of the elements that we have in the system. So here we have perspective reporting and perspective business services. And I also want to remove one of those lines. Most probably it will be this one. So currently I've added just names because it's just the name selector. Now I want to say that I don't want to show them, to say because if we write just a name, this means we want to add it. If we add exclamation mark just before that, then this means that we want to exclude those views from the user. Let me rerun console with normal scaling, user and groups, and change this one password to empty. Okay, and now let's log in with this user. Now you can see here we have the list without business services and reporting. In the same way, you can change also those tabs. You can hide some tabs or you can hide the entire perspectives from the user. You can even add those rules to everyone. If you for sure know that you won't use reporting, it just won't bother you here. And it's really useful when you have a small screen and not all elements might fit inside, especially in the web. Okay, another option for the user that we will create is to add user that won't have anything except dashboards. So, for example, you have some operator that needs to only view elements, not modify them. Like in your case, you will for sure also configure that this user has only access rights to the dashboards and access to exact nodes that he needs to read data for the dashboard. But in my case, it's just for the visibility. I'm okay for this user to be able to do other stuff, but it won't be just visible on the UI side. So that's why I'm adding this user under admin, and the same in access rules. What I want to say. I want to say that I want to exclude everything. In this case, there is hierarchy. First, we have inclusions with just a name. Like if something is added with just a name, it's first level. Then we check if something is excluded. If something is excluded, we will exclude it. And then there is another layer of a check if something after the exclusion can be included. Why it's done so? Because you may want to leave this star in everyone group, because usually you want every user to see everything. But for exact user or for exact group, you want to define that this user should not see anything except perspective object dashboards. Yeah. I need to add this sign. This means that after we included everything, then we excluded everything, then this means that this line will overwrite exclusions. Let's check the user. Let's change the password. Let's log in with the user. And you can see, I see only dashboards. I can't see now, so I've added perspective, but I haven't added any views that I can see. And as we excluded everything, I don't have here dashboard view. You can see it here, but you can't see it here. So now I need to add to operator view dashboard view. And we also want to say that after we excluded everything, this should be included. So let's relogin again. Now I can see everything that I wanted this user to see. So I excluded everything, and then I included specific view and specific perspective. So it might be really granular, but I want to mention again that it's only about visibility, not the security, because this user can't do it through UI, but he still can do all the actions with objects through the API, through the Java API, and Excel, and other options that this user can have. So it's only for visibility and for the clearing the view. That's all from my side today.
Have a great day and see you on the next webinar.
Thank you. Bye.